we were looking from a top view down, what I'm going to do is I'm going to draw north, south, west, and east here. And I'm going to put the tower in red right there at the middle. Okay. Now David, which I'm going to use the color blue for, David's due north. So here's David, and if I draw a blue line here, that's the length of David to the tower. And then a bearing, remember bearings start at north. A bearing of 175 degrees means that this angle from north is 175 degrees. And so we'll go to green for Brenda. Brenda is somewhere on that angle. I'm going to put a B for Brenda. Draw a line. That's the distance between Brenda and the tower. So there's a top view. You can't see the height of the tower because you're looking straight down. It's just a dot. Now for the side views, I would see that height of that tower. I know that it's 35 meters tall, and I know that David is looking at the tower. This is the length that David is away, so maybe I'll do David's triangle first. And the angle of elevation up to the top of the tower is 70 degrees, and since it's tower going straight up, we would know that that's 90 degrees right there. Same thing, we can draw a triangle for Brenda. Again, in red, the tower is 35 meters tall. Brenda, don't know how far away she is, but I know her angle of elevation is 50 degrees, and again, this is 90 degrees there. So I'm color coding here so that the red dot represents the tower, but when you look at a side view, you can see the whole tower. From the top view, you could just see the point of it. The blue line is the distance from the tower to David. See how that matches up with the blue line on the side view? And the green line is the distance from Brenda to the tower. See how that matches up? So we can imagine, can you imagine taking this triangle, picking it up, and marking the red on the dot and the blue line on the blue line? And the green one, sort of visualize picking that up, putting the green line on top of the other one, and it's standing up straight. And now we are going to try, so our art skills maybe come in a little bit. We're going to take this top view and side view and put it together into a three-dimensional view. So what you have to do a three-dimensional view, you have to sort of imagine picking this top view up with the triangles glued on in the right spot and sort of tilting it so that you can see everything. And one of the ways you can create a tilted view is still have your west and your east here, but now on an angle, put your north-south. It's like it was on a piece of paper and you put it down on a table, and this is what you see with a three-dimensional view. Now your tower in red comes straight out from there. And we know that this tower is 35 meters tall. David is on the north somewhere. Here he is. This is that blue line. But now we can see the triangle there, and there would be a 90 degree right in there of that triangle. We know that this angle right here is 70 degrees. And Brenda, at an angle of 175 degrees, so 175 degrees, her point would be about there. This is her distance from the tower. There's still a 90 degree right there. And from this point straight up to the tower, that's her angle of elevation, 50 degrees right there. So now we took the top view and the side views and put them together in a three-dimensional view. And I can put a B here for Brenda. And what the question is asking is, how far is it from Brenda to David? So we can see that on the three-dimensional view. You can also see that nicely. That line would be also on the top view. So this question made a lot of triangles. We want to solve for the purple line And if I look, that's part of a triangle on the top view, but unfortunately, on the top view, can you see that you only know the one thing, the 175-degree angle? You don't know anything else about that triangle. And what do we need to solve a triangle? We need 3 pieces of information, as long as those 3 pieces of information aren't 3 angles. But anything else, you can solve it completely. When we look at the side views, hey, that's a right angle triangle. You're allowed to use SOHCAHTOA. Do you know 3 pieces of information? We do. We have a side and we have 2 angles. We have 3 pieces of information. You can solve those triangles completely. So what I'm going to do is I'm going to be like, okay, well, what parts of these triangles are actually helpful for solving for the purple line? And looking at the purple one here on the top view, I would need the blue line, so I'm going to just go alphabetically here. I'm going to use this as A and call this B. And then if I can solve for A and B, I can label those on my top view, and then I'll have enough information. I'll have 3 pieces of information. Hopefully I can solve that triangle as well. So we'll start off with finding A. And if I want to find A, well, SOHCAHTOA here. A is the adjacent side. I know the opposite side, so I would use tangent. Tangent of 70 degrees is opposite over adjacent. And you can multiply both sides by A and divide both sides by tan of 70 to get A by itself. And we'll go to our calculator here. And I want to show you some things with our calculator that are really helpful. So I do 35 divided by tan of 70, make sure, yeah, I'm in degrees. And I get A is 12.739. The 3 decimal places. So on my triangles, I've now figured this out, 12.739, which means I know on this one, excuse me, I'm not going to label anything more on my 3D view. My 3D view is already pretty, like, filled in. It's going to get, I think it might look too busy if I start labeling too much. And I don't actually need my 3D view to solve, because I'm going to use my top view to solve for the purple line in the end. Now, does it make sense that we're going to need this value later? And in math, if you round early, it could cause your final answer to go off. So I'm going to show you some tricks that are really nice on calculators. On this one here, I'm going to take this answer, and right above the on button is a store button. And you can store your answer as a lot of different things. What I like in particular storing here is I call this A, so I'm going to push alpha and A and store it as the letter A. Because then if I want to use it later, I'm like, oh, what did I call that? Oh, A is what it was called originally. I'll store it as A as well. Now I'm going to do the same thing. I'm going to find B.
Can you get a chance to give me a break for 10 seconds or start with this?
Here, I'll do that right now. Switching to green. If I want to find B, same thing. I have a right angle triangle. I can use SOHCAHTOA. I know that I have the opposite side, and I want to find the adjacent. And once again, you could multiply both sides by B, divide both sides by tan of 50. And we get B by itself. So I'll go to my calculator again. 35 divided by tan of 50. 29.368. And just like last time, I feel like I can label this on here, 5.368, and on my main triangle, I now know this here is 25.368. And I'm going to need that later as well, so I'm going to go to my calculator, and I'm going to store that one as the letter B. So I've stored A as a value and B as a value. Yes?
25 on the graph, like on the triangles.
Oh, I wrote 20, yes, thank you. 29, thanks for noticing. started off with 29, and then the memory faded. Another good reason why it's important to store, because if you wrote something down wrong, using the stored values would at least get you the correct answer in the end. So now looking at my top view, now in this top view triangle, I have three pieces of information. I have the 175 degrees, I have the green side and the blue side, so I can put, I don't know, I'll use purple. There we go, X, right? Because this is what we wanted to find, was how long it was from Brenda to David. Okay, that triangle, however, is not a 90-degree triangle. So we are not able to, oh, well, isn't that wonderful? We just had a magical error happen on our diagrams. So we are going to just recreate the last triangle and not redraw everything. We had, from our top view, we had this length to David. We had this angle of 175 degrees, and we had this length to Brenda. And I don't even remember what these numbers are. 29 point something. And 12 point something. And we want to solve for this. So, we can't use SOHCAHTOA because it's not a 90-degree triangle. We want to solve for X. Do we have an angle and the opposite side that we know both of them? We have an angle, but we do not know its opposite side. So that tells us we can't use the sine law. So we have to use the cosine law, and on our formula sheet, the cosine law looks like this. And the important thing is not the letters, is that there's only one thing that's connected to something else, and that's side C and angle C. So in my situation in purple here, if I want to find x squared, and I'm going to leave some space here, that would go with the cos of 175 degrees. What I put as the other values, well, I can just put in the blue numbers squared, which I don't remember. This actually works out really nice that I don't remember them. Because I'm just going to leave, maybe I'll just leave dots. And we would put those numbers in. And what's the nice thing about those dotted values, doesn't matter which one is A and which one's B, but I've stored them in my calculator. So I can do A squared plus B squared minus 2, and I saved A and I saved B, times cos of 175 degrees. And I get x squared is 1770.189. And now I can get x by finding the square root of that answer, 42.074. And here's where I'm going to need your help. Because normally at this time I would say, I'm going to scroll back up and read the question that magically disappeared when the program crashed. So that's a little bit of a problem. Did it tell me what it wanted me to round to? Does it tell me the units in this question?
To the nearest meter.
To the nearest meter, so that I can round this correctly and make sure that I remember my units. So again, reading the question at the end, very important. All right, questions to do for practice on this one, 9 and 12.